Okay, I thought I would give you an example of how to work one of the not just purely computational problems. So this is page 11, number 25 in our text. Find an equation involving GHK that makes this augmented matrix correspond to a consistent system. So you can see what this is. It's x1 minus 4x2 plus 7x3 equals this number g. Nothing here, so it's 3x2 minus 5x3 equals h, and it's negative 2x1 plus 5x2 minus 9x3 equals k. And it says, let's get some kind of condition, actually find an equation involving GHK that makes this augmented matrix correspond to a consistent system. If you're kind of thinking, well, I don't even know what that means, or we talked about what consistent means. Consistent means actually has a solution, right? Well, if you look at that and say, I don't have an idea how to figure out what GHK need to be so that that works, let's just kind of go forward with what we know we can do. We know now how to put a augmented matrix, the augmented matrix of a system, in triangular form and then back substitute, right? Let's go ahead and put it in triangular form. We know what happened in the last example of lecture 1.1. We put it in triangular form and we saw that the system was inconsistent, all right? So we should be able to tell things about consistency or inconsistency, whether we have a solution or not, by putting the thing in triangular form. So even if we're just like not really clear how to do the problem, let's proceed to put it in triangular form and see what happens. All right, so I'm going to do my row operations to turn this matrix into one that has the lower triangle of zeros, right? A 0, 0, and a 0. Okay, so I have a 1 there, so I'm going to keep that row the same, I think. So I'm going to have a 1, a negative 4, a 7, and the right-hand side is g. I don't need to do anything to the second equation. It already has a 0 where I want it. Now what I'm going to do is I'm going to double the first line, first row, and add it to the second row here, right? So I take, let me just go right here, 2 times 1 added there gives me 0. 2 times negative 4 is negative 8, added there gives me a negative 3. 2 times 7 added is 14, added down there gives me a positive 5. And a 2 times g added to k gives me, I just can write it as 2g plus k, right? That's some number, I just don't know what it is, but it's 2g plus k, definitely. Okay, next, I think I have room to fit this. I'm going to keep my first row the same, and I think I'm going to keep my second row the same. But now look, if I want to get a 0 right there, all I got to do is add straight down. So I'm going to add the second row onto the third row. So when I do that, 0 plus 0 is 0. 3 plus negative 3 is 0, but then negative 5 plus 5 is also 0. And then I have h added onto here, so don't I get 2g plus k plus h? All right, well, I have my triangle of zeros, and I said I also got a bonus 0 here, which I said, hey, that's fine, that can happen. But do you remember what happened in the last example? We had, essentially, it's all zeros, and then here was a non-zero number, right? In the very last example, I think it was all zeros and maybe a 1. I don't remember if it was a 1, but it's a non-zero number. And so the conclusion was that 0 equaled that non-zero number, which makes no sense, which means there's no solution, right? So if 2g plus k plus h is not 0, then the system is inconsistent. Okay? So what does it say here? It says find an equation involving GH and K that makes the corresponding system consistent. Okay, well, I can tell you right now that if we had a row of all zeros down here, that would just say, if this were 0, that would say that 0 equals 0, and there's nothing wrong with that, right? It just says that this third equation isn't giving us any information. We will learn later on that what that means is as long as we don't have a row where it's 0 equal a non-zero number, all zeros equaling a non-zero up above, which we don't, then that will mean that the system is consistent and actually has infinitely many solutions. All right. But the important thing right now that I want to make sure you understand is that the only way to get consistency, and we will have it, is if that's 0. So 2g plus k plus h has to equal 0. There is the equation involving g, h, and k that will cause the system that has this augmented matrix to be a consistent system, to have a solution. In fact, doing this will cause it to have infinitely many solutions, but like I said, we'll get to that later. If that isn't 0, you're inconsistent. That's all.